So this whole module is about learning long division, synthetic division, and then using those to determine whether or not a factor gives you a zero. All right, we want to find zeros, and the reason we want to find zeros is that finding zeros helps us graph and helps us solve these polynomials. So I want to remind you first our strategies for finding zeros that we have until now. All right, so our first one is this division thing. We can decide, is x minus 3 a factor of this polynomial? Okay, so let's do that first. Is x minus 3 a factor? Well, if I'm looking to see if it's a factor, I'm trying to decide, is the remainder 0 when I divide? So I'm going to go ahead and do synthetic division. I'm going to put my coefficients here, 2, negative 15, 22, and 15. And then I say what value of x makes this 0, and that is positive 3. So having set up my division problem, I'm going to do the division out. 2 down to there, and then I'm going to multiply. 3 times 2 is 6, negative 15 plus 6 is negative 9, 3 times negative 9 is negative 27. This comes to negative 5, watch those negatives, and then 3 times negative 5 is negative 15, and this is 0. Okay, so is x minus 3 a factor of p of x? It certainly is, because my remainder is 0. Let's finish this factoring problem then. If x minus 3 is a factor, then I know that this quotient, which is 2x squared minus 9x minus 5, all right, times the thing I divided by, x minus 3, is going to equal p of x. All right, so I just broke this up into two factors. One of them is x minus 3, and the other one is the quotient when I divide x minus 3 out. Well, this 2x squared minus 9x minus 5, we could probably factor that out further. So you can use whatever method you want. I'm going to look at an AC method. I'm going to do this over here in purple. So if I'm using the AC method, I say, well, that's negative 10. A times c is negative 10. Two numbers that multiply to negative 10 and add to negative 9 are negative 10 and 1. And then I'm going to split the middle. So I have 2x squared minus 10x plus x minus 5. And I'm going to squiggle here, squiggle there. I'm going to pull out a 2x as my GCF of the first two terms, and I have x minus 5. I already have x minus 5 here, so I'm going to pull out a 1 as a number holder there, placeholder, and I have x minus 5. So my common factor here is x minus 5. My leftovers factor is 2x plus 1. So now I've factored out this polynomial here into these two factors. What that means is p of x has three factors. It has this factor, and this factor. If I multiply these three yellow highlighted factors together, then I would get back to this original problem. Okay, so we can write p of x in standard form, all right, which is what the original problem said, or we can write p of x in factored form. And p of x in factored form is x minus 3, which was that first factor, and then the purple version of this factor. So x minus 5 and 2x plus 1. Now I have p of x in factored form, and once I have it in factored form, I can find its zeros and I can graph it like we did in the previous module. Another way I have to find zeros, another way to find zeros is by factoring. So we have a couple factoring techniques, and I just want to remind you of them. If you have a cubic like this, well, what we know to do right now is to see if we can factor it by grouping. So I'm going to squiggle here, squiggle there. I'm going to pull out an x squared for my first two terms, and I'm left with x plus 4. I want to be left with a positive on the inside here, so I'm going to pull out a negative 9, and I'm left with x plus 4. So I have a common factor of x plus 4. I have a leftovers factor of x squared minus 9, This x squared minus 9 can be factored further, right? It's a difference of squares, so I can factor it into x plus 3, x minus 3. So now I can say p of x in factored form is x plus 4 times x plus 3 times x minus 3. So that's one way we have going from standard form to factored form, is just factoring by grouping. Another way is by u substitution. So in Module 2 we talked about u substitution when we talked about all our factoring methods. So if you don't remember, please go back and make sure you do remember how to use u substitution. In this case, I know that 4 is twice 2, so if I square x squared, I get x to the 4th. So that means I'm going to let u equal x squared, okay? U squared then would be x to the 4th. And I'm going to substitute in my u's. So now I have u squared minus 5u plus 4. I'm going to factor that. That is the same as u minus, oops, I said x. I said u and wrote x. U minus 4, u minus 1, okay? And then I'm going to go back and resubstitute in this x squared for u. So I have now x squared minus 4 and x squared minus 1. Well, both of these are difference of squares, so let's break them up into their conjugate pairs. This first one is x plus 2, x minus 2. The second one is x plus 1, x minus 1. And what we have here is a fully formed, or a fully factored version of p of x. Okay, so we were given p of x in standard form, and using u substitution, we were able to put it into factored form.